So in our first lesson, we learned that we named a matrix by doing its rows by columns. The X, when you write it out, is rows by columns. And we learned that we could add or subtract them if they were exactly the same dimensions. And we learned that we could multiply any matrix by a scalar by simply thinking of it as distribution. Well, now we're going to multiply two matrices together. And we can only multiply two matrices together if the number of columns in the first row is the number of columns in the first matrix is the same as the number of rows in the second. So you note that they are not the same. So here I have 3 by 2 matrix because I have 3 rows and 2 columns. Over here I have a 2 by 2 matrix. I can do A times B because these numbers in the middle are the same, or the columns here and the rows here, but I cannot do B times A. So multiplication is not commutative when it comes to matrices. If I were to try and flip these around, I wouldn't have the same number of columns as I do rows in my second number. So let's talk about how we actually do this. So I have a matrix here that is 3 by 2. This one is 2 by 3. I'm going to multiply them together. It's a little bizarre. I hope you're ready to do this with me. Okay? You're going to go across and down at the same time. Here's what I mean. You're going to multiply these two entries together because they're in the first location. So this is -1 times -3 is +3. Hang on to that number. I'm going to then multiply going across the row and down the column. What is 3 times -4? -12. So +3 and -12 makes what? -9 when I combine them. And that is going to go right here because it's my first entry in my matrix. Let's do another one. If I go to the second row and I use these values, I do 4 times -3 is -12. -2 times -4, +8. -12 plus +8 is -4. Let's do another one. 5 times -3 is -15. 0 times -4 is 0. -15 plus 0 is -15. Now to do my second column, I kind of ignore this one, and now I go -1 times 2 is -2. 3 times 1 is 3. -2 plus 3 is 1. 4 times 2 is 8. -2 times 1 is -2. 8 plus -2 is 6. Oops. 10, 0, 10. All right, here you go, you try it. Either pause or just follow along and I'll keep working. -2, 0, -3 gives me -5. -4, -1, +2. -4 and -1 is -5, and +2 is -3. Move to the middle. 4, 0, 3, 7, 8, 0, -2, 6, 2, 0, -3, 4, 0, 2. There you go. All right. So now let's look at this. Here's a 2 by 2 matrix multiplied by a 2 by 2 matrix. 3 times 1 is 3. 4 times 0 is 0, so that's a 3. -2 times 1 is -2. 5 times 0 is 0. 4 times 1 we notice that these come up to be the same. That's because if you look at this particular matrix, all of the entries are 0 except for the main diagonal where they're 1. So that means that it's an identity matrix. And when you have an identity matrix, you just get the same thing out. It's like multiplying by 1.